Hello students. Well, in the previous video we discussed about the capacitance of a conductor. Today we will talk about the capacitors. While defining the capacitance of a conductor, we used to say that capacitance of a conductor is the ratio of charge given to the conductor to raise its potential. The ratio of charge given to the conductor to raise its potential. That is the capacitance of the conductor. So today we will talk about the one device, that is capacitors. And these capacitors we oftenly use in our daily life, as we can use the mobile phones. We can hear the songs from the radios where capacitors are used. Say that in summer season we use fans so much times to increase the speed, that regulator that works on the capacitors, right? So what are these capacitors, how they works, how we can say that capacitors are said to be the energy store. Alright, so capacitors are nothing but what the devices that is used to store the electric charges. Capacitors are the devices used to store the electric charges. It is a device. It is a device used to store electric charges. Used to store electric charges. This device which stores the electric charges, whatever the electric charge stored in that device, it is in the form of electric potential energy. It is in the form of what? Electric potential energy. I write the symbol of this capacitor here, symbol of capacitor. Symbol of this capacitor is like this. There are two parallel lines with small separation. This is called the capacitor. This is the capacitor. This is the symbol of the capacitor. The symbol of capacitor. These are the two ends for the output connections for the electricals. Right? So then how it works? How it works? Say that there is one conductor. Capacitor simply is a device, as I said, which stores the charges. How the device looks? The two conductors are separated. The two conductors are separated and the energy is stored. The energy is stored. This is the form of the capacitor. This looks like this. So there is two conductors, two parallel conductor separated by small distance d, separated by small distance d, with medium or without medium, you can say that here. And in this separation between these two parallel plates of the conductor, there is an electric field. How this electric field is stored into the capacitor, that will explain with the help of the diagram now. Right? For that we will talk about the principle of capacitor. Principle of capacitor. Principle of capacitor, it explains the how the charges stores inside the conductor. How the charges stores inside the conductor. Say that I am explaining here about how the capacitor stores the electric charge. Say there is one conductor, and it is positively charged. It is positively charged, called A. There is one conductor A which is positively charged on the surface. What I will do, I will bring one neutral conductor or uncharged conductor close to it. I will call it as B. B is the uncharged conductor placed close to the conductor A. Then what happens? The charges present inside the conductor get experienced force of attraction as well as the repulsion. We know that in this conductor there are positive charges and negative charges. Equal number of positive charges and equal number of negative charges. So by the method of induction, we have studied the method of induction, inducing the charges in the first chapter. So at the one face of this conductor, and negative charges are induced. Negative charges are induced and equal amount of positive charges are produced on the other face of this conductor. Other face of the conductor. Hence it becomes what? Neutral. Uncharged, because the same amount of charges are on one side of the or one face of the conductor and equal opposite kind of the charges are other end of the conductor. Right. So due to induction, a negative charge is induced on the one face of the surface B and opposite kind of the charges are produced on the other surface of the B. Right. So these induced negative charges, attracts this positive charges of the conductor A, and they try to decrease the potential of A. Because of what? Negative charges are close to the positive charges, then there must be the force of attraction. This force of attraction that makes the conductor A to decrease its potential. Alright, then what I will do, the next thing, I will do the conductor B, which is positively charged, I will connect it to ground. When I make the positive charges ground level, all these positive charges will come across to the ground now. What remains only here? The negative charges. On the surface of the B, only negative charges are available now. Only negative charges are available. Now what happens here? Now there is one conductor A like this, and B, which has only the negative charges, all the positive charges are grounded. What remains? Only the positive and negative charges. So this positive charge and negative charge produces the electric field between them. A conductor A has positive charge and now conductor B has negative charge. They produce the electric field now. Right. So this negative charge, what it makes? It makes the potential of A decreases. The potential of A decreases due to the B, conductor B. When the potential of B decreases, what happens? We know that C is equal to Q divided by V. When the potential of any conductor decreases, its capacitance increases. When potential of any conductor decreases, its capacitance increases. So this becomes what now? It acts as a capacitor now, because its potential decreases. Since its potential decreases means what? Its capacitance increases now. So when I say that capacitance of this conductor increases, what I will do, I will add one more charge, I will add two more charges, so that it will increase its capacitance. So capacitance can be increased by decreasing the potential of another conductor. By bringing a uncharged conductor close to the charged conductor, we can decrease the potential of that charged conductor. When the potential of the charged conductor decreases, it means that its capacitance increases. Its capacitance increases. So this is how we can store the electric charges to the capacitors. As the name says that it is a device used to store the electric charges. Used to store the electric charges. So how we can store the electric charges? By decreasing the potential of the other conductor or this conductor. We can increase the capacitance of this conductor. Alright. So this is the symbol for the capacitor. Whatever the capacitor this stores the charges, this stores charges are nothing but the electric potential energy. It stores in the form of what? Electrostatic potential energy. Electrostatic potential energy. Alright. So now there are three types of the capacitors. There are three types of the capacitors. Three types of the capacitors. Say that here, I write here types of the capacitors. Types of capacitors. One, parallel plate capacitor. Parallel plate capacitor. Second one, it is spherical capacitor. Spherical capacitor. And the third one is cylindrical capacitor. Cylindrical capacitor. So these are the three types of the capacitors. One, parallel plate capacitor, spherical capacitor, and third one is a cylindrical capacitor. All these three forms of the types of the capacitors are used in the electrical equipments, instruments. We oftenly use the cylindrical capacitors in remote controls, spherical capacitors in televisions, parallel plate capacitors we often use to store the charges. Right? So for our syllabus, we have only the parallel plate capacitors. We have only the parallel plate capacitor. What is meant by this parallel plate capacitor now? We have only the parallel plate capacitor. So parallel plate capacitor is, as I said, that two parallel conductors separated by small distance. Two parallel conductors separated by small distance. Parallel plate capacitor is a capacitor where the two parallel plates of the conductors are separated with the small distance. This is one parallel conductor, this is another parallel conductor. They are separated by small distance. As I said that there is a positive and negative charges. Inside the space between this capacitor, there is an electric field. There is a electric field like this. We know that stars electric field is direction from the positive to the negative. So there is a electric field inside the capacitor. Right? Outside the capacitor there is no electric field. E is 0 at this, at here. But in between the parallel plates capacitor, there is an electric field, right? We know that is E is equal to sigma by 2 epsilon naught. You have studied, and that is what here the electric field is present in between the two plates, right? So there is an expression for the parallel plate capacitor which is usually asked in the examination for the 3 marks, that we will discuss in the next class.